Hi, today we're going to be looking at equivalent fractions. Let's get started. Okay, so the first thing that we want to do is define what equivalent fractions are. Equivalent fractions are different fractions that name the same number. So let's look at this diagram here, okay? Let's consider the following diagram. And how would you represent this as a fraction? Well, someone might say it's 2 out of 5. Would this be correct? Well, let's have a look. There are two columns that are shaded. That's one column, that's second column, out of 5 total columns, right? So this is column 1, column 2, column 3, column 4, column 5. Two columns are shaded out of 5, 2 out of 5. That would be a correct way of representing it. But someone might also say, you know what? I think it's 6 out of 15. Would this be correct? Well, if they were to justify it, they could say, well, there's this square, that's 1, 2, 3 squares, 4 squares, 5 squares, 6 squares, right? That are shaded out of 15 total squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 6 shaded squares out of 15 shaded squares. Well, that would also be correct. So which one is it? Is it 2 out of 5 or 16 out of 15? The truth of the matter is they're both correct. These two fractions represent or name the same number. They represent the same thing. They're equivalent fractions, okay? Let's talk more about equivalent fractions and how you could make equivalent fractions. Okay, so here's a rule that you want to remember. As long as you multiply the numerator, remember, so this is the uh, uh, numerator and this is the denominator. So as long as you multiply the numerator and the denominator by the same number, you do not change the value of the fraction. The same is true when you divide. So if you were to divide the numerator by, if you were to multiply the numerator by 2 and the denominator by 2, whatever you get, that would be an equivalent fraction. So in our previous case, we had the 2 over 5. So 2 over 5 can be multiplied by 3. And for to multiply both numerator and denominator by 3, we would get 6 out of 15. Same thing, we could also make an equivalent fraction if we were to multiply by 4. So if we were to multiply both by 4, so 2 times 4 is 8, and 5 times 4 is 20. So another equivalent fraction is 8 over 20. You could imagine I could make infinite amount of equivalent fractions. I could multiply this by 5, right? And 2 times 5 is 10, and 5 times 5 is 25. Well, 10 over 25 is an equivalent fraction of 2 over 5. So these are all equivalent fractions. Okay, let's do some questions together, see if we could really solidify our understanding here. So this question says, write 3 equivalent fractions for each of the following fractions. Okay, so let's start off with 2 over 3. Okay, let's multiply both numerator and denominator by 2. What do we get? We get 4 over 6. That's an equivalent fraction. Okay, if we were to multiply each by 3, what would we get? We'd get 6 over 9. That's also an equivalent fraction. If we were to multiply both by 4, what would we get? Well, you'd get 8 over 12. That would also be an equivalent fraction. So 4 over 6, 6 over 9, and 8 over 12 are all equivalent fractions of 2 over 3. We could do the same thing here. We could multiply these by 2 and we would get 10 over 12. If we were to multiply them by 3, for example, so multiply that by 3, multiply that by 3, we would get 15 over 18. And if we were to multiply them by 4, you would get 20 over 24. These three are equivalent fractions of 5 over 6. Now, I'm doing all the multiplication by 2, 3, and 4. Now, what happens if I were to multiply them by 10, for example? Well, it would still work. 40 over 70, that's an equivalent fraction. What happens if I were to multiply 4 over 7 by 5, let's say? Well, I would get 20 over 35. That's also an equivalent fraction. What happens if I multiply both by 236? Well, I don't know the answer because I can't do this in my head, but whatever the answer would be, it would still be an equivalent fraction and the answer would be correct. So let's just do by 2 since that's way easier to do in your head. So it's 8 over 14 and that's an equivalent fraction. So something to remember, it's probably easiest for you just to use small numbers when you're creating equivalent fraction using multiplication. So multiply by 2, uh, multiply by 3, right? Because these are easy numbers to multiply by. 9 over 18, and if we were to multiply 3 over 6 by 4, we would get 12 over 24. So 6 over 12, 9 over 18, and 12 over 24 are all equivalent fractions. Okay, hope you've enjoyed.